So our goal for today is going to be to solve quadratic equations using square roots. In other words, since we already have a square, we're going to take the radical, take the square root of both sides. So let's just jump into and see what we have to do here. Remember, in algebra, our goal always is to get x by itself. So I'm going to add the 75 to both sides here. So now I have 3x squared equals positive 75. Now I need to get rid of the 3, so I'm going to divide by 3. Remember, my goal is to get x by itself. Since there's only one x that's being squared, I can get it as much by itself as I can. Now, how do we undo a square? We take the square root. Now, please pay attention to what I'm going to do right here. Every single time at this step, what you should actually do is attach a plus or minus to it. Let me show you that symbol again. That's an ugly symbol. It's actually a plus with a negative underneath. In other words, we have two options. Either we have the x is positive 5, because 5 times 5 is 25, or x is negative 5, because a negative squared is also positive. So here would be my two solutions. Every single time, we're going to put plus or minus. The only time we don't is when the radicand is 0, because you can't have a negative 0, or positive 0 for that matter. Now let's look at another type here, where we might end up with a fraction or something that's not a perfect square to begin with. So let's see here. Again, I need to get rid of the 49. Remember what we're trying to do. Essentially what we're doing, and this is for every math problem, is we're trying to undo the order of operations. So remember, the order of operations are do your grouping symbols first, your exponents, you do them. When you're simplifying, you go this way. The last thing we do is adding and subtracting. But we're not simplifying. We're unsimplifying. We're unpacking things. It's like your cell phone is on the bottom of this pile of all this crap that you put onto it. So what are you going to do? I'm going to take the stuff off the top first, and then that stuff, and then finally it's uncovered. So the stuff that's furthest away from my phone, which is on the bottom of the pile, I'm going to unpack. Kind of what you're thinking here too. Here's my x. 3 things are happening to the x, right? There's a square here, there's a times 4 here, there's a minus 4, minus 48. All this is happening to the x. So what's farthest away from it? This guy right here. So I'm going to get rid of that. What's close here? Oh, that's probably the closest because of the square. So I'm going to move that away and then finally move that away. We're unpacking. We're getting rid of all the stuff that's burying it. Undoing the order of operations. All right, so now I have positive 49. Now I'm going to get rid of the 4, and I'm actually going to leave it as a fraction, because we already know how to take radicals of fractions. We did that yesterday. So when I take the square root here and the square root here, don't forget the plus or minus. And so I start to simplify this radical. It may require you to take this over here and simplify it, blah, 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 like we did. But some of you may notice here that the square root of 4 is 2, and the square root of 49 is 7. So actually, there's no real simplification to do besides just work in your head. So here is one way to write the answer. Plus or minus 7/2. Salud. Another way to write the answer is if you prefer to write it as a decimal and you said 3.5 and negative 3.5. Again, I don't care which way you write it. What you're going to find is if it's a word problem, you end up with something like this. 3.5 seconds. If it's a regular old just math problem, most of the time it's left in a fraction form. So in example number 3 again. So I'm going to add the 120 to both sides to get 3x squared equals positive 120. And now we divide by 3 to isolate the square to get positive 40. Taking the square root of both sides means that I have to put a plus or minus there. Now, that's kind of my answer, plus or minus radical 40, But what I'm going to do is make sure to simplify the radical 40 before I write it down as my final answer. So it is plus or minus something, but let me just over here on the side, let me grab the 40. If you want to use the tree factor to do it, I do 4 and 10, and then 2, 2, 2, 5. I look for the things that repeat. Here's a pair of 2s that comes out. And the 2 and the 5 are lonely. They stay in, so the 10 stays in. And this is how you can leave your answer. This is simplified radical form. You don't need your calculator to estimate this. This is leaving it in simplified radical form. If this were a word problem, I probably would calculate it out so I have how many miles or how many seconds something takes. Is sometimes we won't have only the x squared. Sometimes we'll have a binomial or a trinomial or something else. We'll have something else that's being squared. But what we do is we don't discriminate. Just because this guy inside is bigger than or different looking than the other ones we've seen doesn't mean we treat it any different. What we say is, oh, look, I have a square. How do I kill it? So I take the square root of both sides. So what happens here? Effectively, the radical eliminates the square. The radical eliminates the square. So what is left? It's the radicand. The expression inside is what's left. Then over here, I have plus or minus 5. Now what can I do? Well, there's a couple different ways to approach it, but for the sake of ease, it's probably easiest or most less confusing to break this up into the two problems that we see. This is not the zero product property. We're not splitting this up because they're equal to 0. Two factors equal to 0 when they are product multiplied together. What we're doing is breaking this plus or minus up into a positive there and a negative there. And now we solve them individually. So here I add 3 to both sides to get x equals 8. And I add 3 to both sides here to get negative 2. So notice, here's a situation where I don't have opposites. Because before we had plus 7, minus 7, plus radical 2, minus radical 2. But here, one's positive, one's negative, but they're not opposites. It's not 8 and negative 8. So let's look here where we don't get what we consider simple and pretty answers. Rather, we're going to get answers that are going to look complicated. So, since the square is already isolated, I'm going to take the square root of both sides. And I bring down the plus or minus. Now, remember that radical 20 can be simplified. And we already did it, but I'm going to show again. Remember, the 2 comes out and the 5 locks in place. So 2 radical 5. So what I did was simplify as I went. Okay, now to isolate the x, I'm going to add 5 here. And here is what we have to think about, what combines. What if I gave you this and I said 5 plus 2a? How would you simplify 5 plus 2a? Thanks. How would you simplify 5 plus 2a? Sort of a trick question. Anybody? There you go, 5 plus 2a. Good. This does not combine any further. This one does not combine any further. It is already simplified. Why? Because of like terms. Well, what about over here? So I changed that to be a subtraction. Now, bring down the x. I bring down the negative 5. I bring down the plus minus 2 radical 5. What? The Gehenna? Yes, this is the answer. The two answers. It's ugly looking, but we know we've simplified. Why? Because this is a whole number, a constant, and this one is irrational. They do not combine further unless you decimalize things. But this one doesn't have a radical attached. Just like over here has an a, this one doesn't. You don't combine them. They're not like terms. In the same way, these are not really like terms. Second, if I did put this into a decimal of some kind to get your 4.6 or something, then I could split it up. But because there's no context of word problem, I'll leave it like this.